অনলাইনে যারা আছিস শুনতে পাচ্ছিস? হ্যালো,
यस सर শুনতে পাচ্ছি।
শুনতে পাচ্ছিস? আচ্ছা, so already we have discussed 2 lectures of this particular chapter. Last day we have completed atomic radius. Okay, how atomic radius changes from left to right? Increases in size, decreases in size. From left to right, decreases, and down the group increases. So first of all, we should discuss some questions related to atomic radius. These are the periodic properties: atomic radius, ionization enthalpy, electron gain enthalpy is quite similar to that of electron affinity. We should discuss electron affinity, electronegativity, and the metallic and non-metallic character. So first of all, we do some practice problem related to the atomic size. Okay, so first some MCQ questions are there. You should give the answer. Those students are in online, you should answer in the comment box. Okay, first how you should arrange the decreasing order of atomic radii. First question, how you should arrange the decreasing order of atomic radii. This is I minus, I and I plus. Out of these three, which one is smallest? Which one is smallest? I plus. After that, I and then I minus. I minus, write down. I minus will be I minus having maximum size, decreasing order, that means I minus maximum size, then I, and after that I plus. Can you suggest any explanation of it? Now what is the explanation behind it? Now see,
differs in the size of a atom depends on the number of shells, and also it also depends on the positive as well as the negative charge on the atom.
Now take an example, small example like sodium plus and sodium minus. How many protons are there? 11 protons, 11 protons, 11 protons. Because cations and anions, they do not have any change in proton number. They all have same number of protons. Now the electron number in case of sodium, it is 11. In case of sodium plus, it is 10. Here it is 12. Now see that force of attraction. Okay, force of attraction. If the force of attraction, nuclear force of attraction over outermost shell is greater, then size of the atom or ion will be smaller. Here you see that 10 electrons are attracted by 11 protons. So proton to electron ratio, this is the proton to electron ratio. As the proton to electron ratio increases, size decreases. So here you see that 11 protons attracts 10 electron. So more than 1:1 attraction. Here proton to electron, in the next case proton to, in case of sodium, here it is in case of sodium plus. In case of sodium, proton to electron ratio is 11/11, that is 1:1. And in case of sodium minus, proton to electron, it is 11/12. So as we see that proton to electron ratio decreases, then size also increases, because force of attraction is less with respect to the other one. That's why you can say that I minus, that having maximum number of electrons, this is one of the important aspect of this question. And another point is that if a particular species contains greater number of electrons, okay, if a particular species contains greater number of electrons, then there is some sort of electron repulsion, some sort of electron repulsion. If you consider sodium and sodium minus, sodium contains 11 electrons, sodium minus contains 12 electrons. So same cell but contains greater number of electrons. So electron repulsion is greater in case of sodium minus or in the case of I minus. That's why I minus electron repulsion increases the size of the atom or ion. So I minus having maximum size, then I plus. Is it clear? Okay. Now second one, magnesium 2 plus, calcium 2 plus and aluminium 3 plus. Magnesium 2 plus, magnesium 2 plus, it contains electron 10 electrons and protons 12. Here you see that calcium 2 plus, it contains electron number 18 and proton is 20, and aluminium 3 plus, electron is 10. हाँ हाँ কমেই তো গেছে, তো কমেই তো গেছে। Here it is 20, so 2 plus is 18, electron number 10 but proton number 13. So what should be the expected order? Decreasing order. Magnesium 2 plus and aluminium 3 plus, they contains same number of electrons, 10 electrons each. Magnesium 2 plus and aluminium 3 plus, they contain same number of electrons. But the aluminium contains greater number of protons with respect to the magnesium 2 plus. So you can say that aluminium 3 plus having smaller size with respect to magnesium 2 plus. Is it clear? Magnesium 2 plus and aluminium 3 plus contain same number of electrons. Okay, they contain same number of electrons. But the protonic charge, that is the effective nuclear charge, previously we have discussed, the protonic charge is greater in case of aluminium 3 plus. So as the nuclear charge increases, the force of attraction of the nuclear charge over outermost shell increases and the size decreases. So aluminium, magnesium having greater size with respect to aluminium. Okay. Magnesium having greater size with respect to aluminium. Now calcium having 18 electrons. Calcium contains greater number of electrons and also the greater number of proton. Calcium it contains 18 electrons, so its cell number is greater. So calcium will be maximum size, calcium 2 plus, magnesium 2 plus and aluminium 3 plus will be the size order like this: calcium 2 plus maximum, then magnesium 2 plus, after that aluminium 3 plus. ঠিক আছে, বুঝতে পেরেছিস? ওকে, না নেক্সট কোশ্চেনে চলে যাচ্ছি। নাও সি oxygen, sulfur, selenium. Oxygen, sulfur, selenium. Those elements are present in group number 16. Oxygen, then sulfur, then selenium. Oxygen having -2, sulfur -2 and selenium all having -2. But because of the fact that oxygen, sulfur and selenium, they are present along down the group. They are present down the group. Okay. As we move down the group, size increases. So the order will be like this: selenium 2 minus, sulfur 2 minus, then oxygen 2 minus. Okay. Next one, S2 minus. S2 minus. Sulfur contains how many? Electron number, element number 1 to element number 20, you have to remember how many electrons they contain. Okay, starting from hydrogen to calcium. Maximum calcium. Here scandium is present, but scandium having 21 electrons. Okay. So sulfur 2 minus, sulfur contains 16 electrons. So 2 minus means it contains 18 electrons. Proton number should not be changed. Proton number as well as 16. Then Cl minus electron. Chlorine contains 17 electrons, but Cl minus, then it is 18. But proton number is 17. After that, potassium plus. Potassium contains 19 electron. But after the removal of 1 electron, then it will be 18. And the proton number as usual having 19. Then calcium 2 plus electron. Calcium 2 plus, calcium contains 20 electrons. Then 2 plus means it contains 18 electrons, but proton number is 20. And scandium, as we already mentioned, that scandium contains 21 electrons. So scandium 3 plus, it contains 21 means 18 electron. It also contains 18 electrons. and proton number is 21. Now all those species starting from sulfur 2 minus to scandium 3 plus, they contain same number of electrons but different species. They contain different number of protons. This type of species is known as isoelectronic species. Isoelectronic means the different species containing same number of electrons. Those species are known as isoelectronic species. Now guess what should be the order? They contain same number of electrons but different number of protons. So what's having smallest in this range? Which one will be smallest in this range? Scandium 3 plus. Scandium 3 plus will be smallest because though they contain same number of electrons, but the species contains maximum number of protons that having greater attraction. Okay. So the order should be the highest, largest in size, that is S2 minus. After that Cl minus. After that along this proton number as the increases sizes decreases. So first S2 minus, then Cl minus, then potassium plus, then calcium 2 plus, then scandium 3 plus. So order should be like this. Clear? Arrange the following in the decreasing order of atomic radii: potassium, sodium, aluminium, silicon, carbon, nitrogen, fluorine. Now, the elements present in higher period with respect greater in smaller in size with respect to lower period, and as we move left to right, size decreases. Now first of all you have to identify which elements present in which period. Okay, so second period, just see second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. These are the second period elements. So here we get the elements: carbon is present here, nitrogen is also present here, fluorine is also present here. After that, lithium, here it is sodium and potassium. So sodium, potassium. Now sodium, potassium, here boron, aluminium, carbon, silicon. Now first consider this particular period. This is second period, this is third period, this is fourth period. So there is no doubt that potassium having greater in size, greatest in size in this series, because potassium is present in the fourth period. So as we move down the period, down the group, the size increases. So potassium in this particular the sequence of elements, potassium having largest size, and which one having smallest size? As we move left to right, the size decreases. So period 2 elements having lesser size with respect to period 3 or 4. Now in period 2 there are several elements: carbon, nitrogen, fluorine. But as we move left to right, size decreases. So fluorine will be smallest. After that, nitrogen is some sort of greater than that of fluorine, and carbon. So these three elements having order: fluorine is greater than nitrogen, nitrogen is also greater than carbon. Now come to the third period. Potassium is largest. Now here you see that sodium, aluminium, silicon. Here you see that silicon having, no, the order should be like this. Left to right size decreases. So carbon having greater size with respect to nitrogen and nitrogen having greater size with respect to fluorine. Just correct it. Carbon greater like this. Okay. Now sodium, aluminium, silicon. Left to right size decreases. So sodium greater than aluminium, aluminium greater than silicon. Now what should be the correct order? Potassium maximum. After that potassium go in this way. Sodium. After that aluminium, silicon, next carbon, next nitrogen, next fluorine. Then বুঝতে পারলি কিনা? Down the group size increases. Potassium fourth period. The potassium having greatest size, the potassium first. Then after that third period. From left to right, sodium, aluminium, silicon, from left to right, size decreases. So, out of these three, sodium is greater than that of aluminium, aluminium is greater than that of silicon. So, sodium, aluminium, silicon. After that, come to second period. Carbon, nitrogen, fluorine. So, carbon having greater size with respect to nitrogen and nitrogen greater size with respect to fluorine. Clear? So, you have to know the relative position of the elements in the periodic table. Just those elements which are actually known as representative elements. Those are present in group 1 and 2 and group 13 to 18. Those elements are actually representative elements. You have to remember where the position of at least up to calcium. Okay, at least up to calcium, the position of elements in the period and then the group, which period they belong, which group they belong. Okay. Now, next one. বলো এটা কি হবে? Arrange the following increasing order of atomic radii: F minus, Cl minus, Br minus, and I minus. In which particular group they are present? Group number 17. Those are known as halogen. Okay, so here you see that those elements are exactly present in down the group. So as we move down the group, size increases. So the order will be I minus, F minus, Cl minus, Br minus. It is increasing order. Okay, so smallest will be first and the greatest size will be last. So F minus, Cl minus, Br minus, and I minus. Hello. देखिए इधर को ट्राई कर दो. This one. Identify the correct order of size of the following. হ্যাঁ, কারেক্ট অর্ডার কে বলবি? অনলাইন? হ্যাঁ, স্টেটটা ইনক্রিজিং অর্ডার। প্রশ্ন কি বলেছে? Identify the correct order of size of the following. That means here 4 different orders are mentioned. Only one is correct. Which one is correct? All the species contains how many number of electrons? একেবারে নিচেরটা কি করে বললি? আচ্ছা, ক্যালসিয়াম, now see, calcium 2 plus, how many electrons? 20. Here potassium plus 18, 19, argon 18, 18, Cl minus 18, 17, S2 minus 18, 16. So maximum size S2 minus, then Cl minus, then argon, then potassium plus, then calcium plus. So first one is correct. Already এরকম একটা করালাম তো, হ্যাঁ? So first one we have already mentioned that if the different species contain same number of electrons, then you have to compare the proton number. If the proton number is greater, then the size will be smaller. First one is correct. Identify the size. নিটের কোশ্চেনে দেখ আছে, তোদের কোশ্চেনে নিটে ঢুকে গেছে এখানে। হিয়ার উই সি অ্যান এক্সেপশন, জাস্ট সি, boron, aluminium, gallium, indium, thallium. As we move down the group, size increases. Here is an exceptional, write down exception, that aluminium is greater size with respect to gallium. So here size will be boron, after that gallium, after that aluminium, after that indium, after that thallium. Okay, this exception you should remember, aluminium and gallium. Aluminium will be, এটা এখন জানতে হবে না, মানে এইটুকু জেনে রাখ, ঠিক আছে? এখানে ফ্যাক্ট জেনে রাখ, এটা শিল্ডিং এফেক্ট, এটা এটা এর মধ্যে ডি ইলেকট্রন ফিলেকট্রন থাকে আর কি, সেটা এখন আর বলছি না। তুই শুধু এইটা, এই ফ্যাক্টটা জেনে রাখ। এরকম কয়েকটা ফ্যাক্ট আমি তোকে বলবো আজকে, সেগুলো একটু জেনে রাখবি। তো বোরন, অ্যালুমিনিয়াম, গ্যালিয়াম, ইন্ডিয়াম, থ্যালিয়াম। বোরন, অ্যালুমিনিয়াম এন্ড গ্যালিয়াম, দে শুড চেঞ্জ দেয়ার पोजीशन, इंटरचेंज देयर पोजीशन। ओके, अदर जो एलिमेंट्स हैं, their position will be same. As we move down the group, the size increases. So the correct order, which one? Correct order D. Okay, correct order D. Okay, the species argon, potassium plus, calcium 2 plus. Already we have discussed this type of question. Same number of electrons, in which order do their radii increase?
সবচেয়ে বড় হচ্ছে ক্যাশ, ফার্স্ট
Hmm? Option B. Okay. Option B, because calcium 2 plus, proton 20, electron 18, potassium plus, proton 19, electron 18, and argon 18, 18. So the correct order is calcium 2 plus, potassium plus, and argon. Okay? ক্লিয়ার ব্যাপারটা? Now the next one, atomic radii of fluorine and neon. See the question. Atomic radii of fluorine and neon are given by first one for fluorine, second one for neon. You don't have to know what should be the exact size of fluorine or neon. You have to think about the conception. What should be the expected size? Here 0.7 to 1.60, 1.60, 1.60, 0.7 to 0.7 to. Now think that fluorine, where fluorine is present, fluorine, and after that neon. We have already mentioned that inert gases having greater in size with respect to the halogens, because we consider van der Waals radius for those elements. So always inert gases should be greater in size with respect to corresponding halogens. So they can never be similar size, 1.60 or 1.60. They can never be 0.72 or 0.72. Then this will be the exact. You don't have to know its size is 0.72 or 1.60 angstrom. Those figures are not so important. You have to think about the conception. That is, the halogens should have the smaller size with respect to the respective inert gases. Okay. So in this way you can answer this one. Someone says that how we should remember the value of their sizes. Not like that. Okay. So atomic radii of fluorine and neon in angstrom unit are given by like this. So we have already discussed some questions related to atomic radii. I think that is clear. Now we come to second periodic property, that is ionization energy. Ionization energy, that can be also written as ionization enthalpy. Enthalpy in some books this is also written, or ionization potential. All those terms having similar meaning. Now let's discuss what is ionization energy and also how ionization energy changes in the group and in the period. So we discuss first of all what is ionization energy. Now think, last day we have discussed two important terms. One is shielding effect. What is shielding effect? And another one is effective nuclear charge. We mentioned that when an atom, it contains protons at the nucleus and it contains different cells where the electrons are present. Now the electrons present in the outermost cell, experience two different types of forces, attractive and repulsive. Attractive force from where? Attractive force from the protons present in the nucleus, and the repulsive force from the inner electrons present in different cells. So the inner electron tries to push outside, and The nucleus tried to attract the electron inwards. So some sort of those inner electrons, they can screen, they can cover the nuclear charge that attract the outermost cell. That type of property is known as screening effect. Now due to screening effect in which inner electron shield the valence electron from the attraction of the nucleus, due to screening, the size, the attractive force of the nucleus over outermost cell decreases, and the amount of nuclear charge that attracts the outermost electron is known as effective nuclear charge. Now, effective nuclear charge you get by the difference of nuclear charge and the shielding constant or screening constant. So if you consider that sodium contains 11 protons, sigma. Suppose sodium contains 11 protons and 1 electron in the outermost shell. Now, what is the amount of nuclear charge that attract the outermost cell electrons? Not the 11 nuclear charge, but due to shielding, some less amount of nuclear charge that attract the outermost cell electron. That is known as effective nuclear charge. So, in order to explain different facts, we want to explain on the basis of effective nuclear charge, not depending upon the nuclear charge. Okay. Now we explain what is ionization energy. Now see, what is ionization energy? Ionization energy, it is the minimum energy. First important point. It is the minimum energy required to remove most loosely bound electron. Up to this we should explain. Minimum energy required to remove most loosely bound electron. What does it mean? See, if an atom contains different cells and those electrons are present in different cells, then which electron is loosely bound? Loosely bound means those electrons present in the outermost cell. In other words, you can say that the electrons present in the outermost cell, you want to remove the electron present in the outermost cell. Why those electrons are loosely bound? Because those electrons are farthest from the nuclear attractive force. If the electrons present farthest from the nucleus, that force of attraction, nuclear force of attraction over that outermost cell will be less. That's why you can say that those electrons present in the valence cell or outermost cell having least electrostatic attractive force. Now, though it is considered that those electrons are loosely bound, but there is some sort of attractive force over that particular electron. So if you want to remove this electron, if you want to remove from the periphery of that atom, then you have to supply some sort of energy, because there is some sort of attractive force between nucleus and outermost cell. So what is the amount of energy? Suppose 2 kilocalorie energy is required to remove an electron from sodium atom. Suppose. Then you have to know that if you supply 4 or 5 kilocalorie, then also that electron is removed. It is the minimum energy. What is the minimum energy? If you want to remove an electron from the outermost cell, you require 2 kilocalories of energy. Then if you supply 4 kilocalorie, 5 kilocalorie, then also electron should be removed. So here, in case of ionization potential or ionization energy, you have to consider what is the minimum energy that is required to remove the most loosely bound electron from an atom. So now this point is clear. Minimum energy required to remove most loosely bound electron. Okay. Now the second line. From an isolated gaseous atom in its ground state. What does it mean? Now, electrons cannot be removed from the solid state, because in case of solid state, they are not only one single atom is present, they are several number of atoms, they are attracted each other. That's why when you want to remove an electron in the solid state, that requires lots of amount of energy, because first of all you have to separate those atoms and you take one single atom, and after that you remove the outermost electron. So ionization energy is not like that. Ionization energy, you have isolated gaseous atom. Suppose you have a sodium atom. Already you have converted sodium solid into sodium gas. Unless and until you convert an element into gaseous form, you can't remove an electron, because in solid form there are so many number of atoms, they are present in a collective manner. That's why first of all you have to separate. So here in case of ionization energy or ionization potential, we remove the electron from element in its gaseous state. Okay. From an isolated means that is separated, not in a collective manner. From in its ground state. Ground state means, let's see, there are two types of electronic structure of an atom. One is ground state, another one is excited state. Suppose it is hydrogen. You consider this is hydrogen atom. So its electron is present here. It contains only one electron. That electron is present in the first cell. Now when electrons are present in the first cell, that type of electronic configuration is known as ground state electronic configuration. Now when you supply energy, two types of energy can be supplied. One type of energy means excitation energy. Excitation energy means, suppose you supply some amount of energy, but electrons do not remove from the atom, but electron can be jumped from first cell to third cell. First cell to third cell. Now electron is present in the third cell. This electronic configuration is known as excited state. When electrons are present higher energy state, then it is expected to be. Hydrogen contains only one electron in its first cell. This, unless and until electrons are not present in the higher cell, then that electronic configuration is known as ground state. If electrons are present in higher cell, then that is excited state. In case of ionization energy, electrons always should be present in ground state. So just consider an atom, electron present in the ground state. You should remove the outermost cell electron. What is the minimum amount of energy required to remove that electron? Is it clear now? So what is ionization energy? Just read out. Minimum energy required to remove the most loosely bound electron from an isolated gaseous atom in its ground state. This type of definitions, in case of this type of definition, each and every term is important. You don't miss out any of those terms. If you miss gaseous state, then there will be no meaning. If you do not mention most loosely bound or the minimum energy, you should start in this way, the energy required to remove. That will be wrong definition. So minimum energy required to move loosely bound electron from isolated gaseous state in its ground state. Okay. Now, if you consider M is an atom, it contains equal number of proton and electrons. Suppose it contains 11 protons and 11 electrons. Now you supply some amount of energy. Here you see proton number will be same and the electron number decreases. In that case, M should be changed to M plus, because here 11 plus and 10 minus. So net 1 plus 1 positive charge excess over that atom. So M plus plus electron. So when you supply energy, then the element should be converted to corresponding cation. Sodium should be changed to sodium plus. Magnesium should be changed to magnesium plus. So ionization energy is one type of energy. So what should be the unit of ionization energy? It is kilojoule per mole, kilocalorie per mole, or electron volt. This type of energy units can be used for ionization energy. So definition of ionization energy and the unit of ionization energy. Now you can remove more than one electron from an atom. Like we already mentioned that magnesium ion, what is magnesium ion? Magnesium ion Mg2 plus. That means 2 electrons removed from the magnesium. Or even you write in this way aluminium 3 plus. So 3 electrons removed from aluminium. So this is not the fact that only 1 electron can be removed from an atom. You can remove more than 1 electron. Now it is a minimum energy, already we have mentioned. Electrons, here some points has been discussed, just already we have discussed. Electrons cannot be removed from solid state of an atom. It has to be converted into gaseous form. Energy required for conversion of solid state to gaseous state is called, directly you convert solid state to gaseous state, sublimation energy. So before the ionization energy, you have to supply some amount of energy also. That energy is sublimation energy, because in the definition we have already considered that you have to convert that element into gaseous form. Unless and otherwise you convert into gaseous form, then electron should not be removed. So some extra amount of energy, that energy is known as sublimation energy. For any neutral atom, ionization energy is always endothermic. Now there are two processes, two chemical processes or physical processes also you can consider. One is exothermic and another one is endothermic. What does it mean? Endothermic means you have to supply the energy. তুমি বাজারে কিনতে গেছো, তো তুমি টাকা দিচ্ছ লোকটাকে, তো তুমি সাপ্লাই করছো, you supply the energy to the system. That is called endothermic. And when a process runs but it releases energy, then it will be exothermic. So here, if you want to remove an electron, then you have to supply energy. Unless and otherwise you supply energy, how you should remove that particular electron? Because electrons are firmly attracted by the central nucleus. So you have to supply energy. So ionization energy or ionization potential is always key endothermic process. This is written in this way, delta H positive. It is measured, already we have mentioned that electron volt per atom, kilojoule per mole, kilocalorie per mole, etc. etc. So clear? যতখানি বললাম? Okay. So ionization energy. Now we discuss the successive ionization energy. Successive ionization energy means after the removal of first electron, we can remove second electron, we can remove third electron also. Higher energy requirements are there, but you can remove. So if you remove first electron, M converted to M plus, and you remove this electron, this energy is known as fast ionization energy. Now M is converted to M plus. Now you take M plus and you can convert M plus into M2 plus. You remove second electron, the second ionization energy, and also in this way M2 plus to M3 plus. Now one important thing, the energy required for the removal of first electron always less than electron removal of the second electron. Why? Just take an example. Suppose sodium. Sodium, it contains how many protons? How many electrons? Now you supply some amount of energy, i.e. 1, sodium is converted into sodium plus. Here you see 11 electrons attracted by 11 protons. Now after the formation of sodium plus, proton is now also 11, but electron is 10. Now if you want to remove second electron, then attractive force per electron. In first case, it is 1:1 attraction. 1:1 attraction. And in second case, the 10 electrons attracted by 11 protons. So attraction is some sort of greater. No? তুমি 10টা চোর ধরেছো, 11টা চোর ধরেছো, 11টা লোক মারছে। তো যে যা নিজের চোরটাকে মারছে। 1:1, আমি আমার চোরটাকে মারি। একটা চোর পালিয়েছে, তো একটা লোক এক্সট্রা হয়ে গেছে। তাহলে 10টা লোক 10টা চোরকে মারছে, প্লাস একটা লোক ঘুরে ঘুরে প্রত্যেকটাকেই মারছে। তাহলে 1 এর চাইতে একটু বেশি মার খাচ্ছে। যাকে তুই এটা ভাব যে here you see that 10 electrons are attracted by the 11 protons. Now after the formation of sodium 2 plus, the electron number still decreases and the force of attraction still increases. So you can say that ionization energy 1 is less than ionization energy 2, or in other words, ionization energy 2 is greater than the ionization 1, or ionization energy 3 or 4. In this way you can write. Is it clear? So as we remove more and more number of electrons from an atom, then because of the fact that proton numbers are same in all those cases and the electron number decreases, so force of attraction of the proton over those electrons increases, and as we remove those electrons, more and more amount of energy required. Okay? Okay. Fast ionization energy. Now we consider the ionization energy. Sodium never forms sodium 2 plus. Aluminium converts aluminium 3 plus, or magnesium converts magnesium 2 plus. Now why this type of ions form. Why sodium should not be converted into sodium 2 plus? Suppose valency of sodium. What is the valency of sodium? Only one. Sodium chloride. You write sodium chloride in this way. NaCl. Can you write NaCl2? Paruna. Magnesium chloride. How we should write magnesium chloride? MgCl2. How you should write aluminium chloride? That is LCl3. So, in case of magnesium, 2 electrons are removed. In case of aluminium, 3 electrons are removed. But in case of sodium, only 1 electron is removed. Now, this is totally depends on its electronic configuration, how the electrons are arranged. If you consider sodium, then sodium, it contains 11 electrons, so electrons are arranged in this way. So, the outermost shell of sodium contains only 1 electron. If you remove that electron, sodium converted into sodium plus, that electronic configuration having 2,8. And as we all know that elements have tendency to convert their electronic configuration into inert gas electronic configuration. Inert gas electronic configuration. So 10 electrons, which inert gas having 10 electrons? Neon. Sodium plus attain the electronic configuration of neon. So sodium plus, if you want to remove the electron from sodium plus, then it will be quite difficult, very high energetic process, because sodium plus already in stable state. Now, if you consider aluminium, it contains 13 electrons. So, remove 1 electron, then it is converted into aluminium plus, but its outermost shell, it contains 2 electrons. It is not converted into inert gas configuration. Now, you remove second electron, it also contains 1 electron in the outermost shell, and after that, you remove this last electron in the outermost shell and 2,8. This is the electronic configuration of neon. So, the second electron removal is higher, but aluminium should remove 3 electrons. That's why the valency of aluminium is 3. But never 4. Because after that, if you want to remove, the 4th electron, then its electronic configuration will be 2,7. That is not the inert gas electronic configuration. So how many electrons you should remove, that depends on the electronic configuration of the element. Mostly the electrons present in the outermost shell, those can be removed. Because of the fact that sodium contains only 1 electron in its outermost shell, so it can easily remove first electron, and that's why the valency of sodium 1. If you consider magnesium, then magnesium contains 2 electrons. So its valency is 2, those 2 electrons removed. Now we consider the factors affecting the ionization energy. What are the factors that can affect? We have already considered the size of the elements. Now think about the fact that you have 2 elements, one having greater size, one having smaller size. Now, just idea, which one having greater ionization energy? In which case the electron removal will be higher energetic process. Exactly so. Because if the elements, why elements are smaller? Due to the force of attraction of the central nucleus. Now if you want to remove that electron, then you have to overcome the high force of attraction of the nucleus. But if the size of the atom is greater, then the electron removal will be much easier. Attractive force is less. So if you have some conception about the radius, then you can guess what should be the order of ionization energy. Now see, as we move down the group, size of the atom increases. So how we should explain the ionization energy? As we move down the group, ionization energy decreases. So simple as that. From left to right, the size decreases. Size decreases, that means ionization energy increases. Clear? So, size or number of cell, greater the size, easier is the removal of valence electron, hence energy required is less. Here you see this is smaller size, here you see that is greater size, so ionization energy is inversely proportional to the atomic size. If atomic size is greater, ionization energy will be less. বই যখন পড়বি মুখস্থ করতে হবে, কনসেপশনটা ক্লিয়ার করবি, ব্যাস। আমি যেগুলো এক্সেপশন যেসব জায়গায় হয় না সেগুলো আমি আলাদা করে বলে দেবো, কিন্তু বাট দ্য মেইন কনসেপশন সেটা কিন্তু সহজেই হয়ে যাবে। তো ইজিয়ার ইজ দ্য রিমুভাল অফ ভ্যালেন্স ইলেকট্রন ইফ দ্য সাইজ অফ দ্য অ্যাটম ইজ গ্রেটার, inversely proportional. Now another one is nuclear charge. Nuclear charge or effective nuclear charge. Greater the charge, greater is the attraction between the nucleus and electrons present in the outermost cell. Removal of electron is difficult. Greater the charge, greater will be the ionization energy. We take some example. দেখ একটা এক্সাম্পল দিচ্ছি। আয়রন 3 plus, iron 2 plus, ion with high positive oxidation state. Oxidation state means this charge present, that atom is known as oxidation state or valency state. The charge present in an atom is known as oxidation state or valency state. As the charge is greater, what does it mean? Charge is greater means it contains greater number of protons with respect to the electrons. Now, if we want to remove the electron from iron 3 plus, just you want to remove an electron from iron 3 plus, just think about the fact that iron already contains 3 extra protons. Now, if you want to remove an electron from iron 3 plus, that needs the greater amount of energy with respect to iron 2 plus, because iron 2 plus or even iron contains same number of electrons and protons. So as the positive charge increases, the ionization energy or energy required to remove electron also increases. In other words, you can say that O2 minus O minus O. Which one having greater ionization energy? If you want to remove electron from O or O minus or O2 minus, what should be the order? Greater amount of energy in which case? If order should be like this. Because O2 minus, it contains greater number of electrons already present, less number of proton. If it contains positive, then greater number of protons are present. If greater number of protons present, then electron removal will be difficult. But if it contains greater number of electrons, 2 minus, 3 minus, what does it mean? It contains greater number of electrons with respect to the proton. It already has less attractive force because it contains less number of protons. That's why it containing that negative charge. Why oxygen 2 minus is present? Because it contains if oxygen contains 8 protons, then electron already 10 electrons present. So we see that O2 minus having less energy needed if you want to remove from electron from O2 minus. So ionization energy is directly proportional to positive charge. As the positive charge increases, ionization energy also increases. But ionization energy inversely proportional to negative charge. If the negative charge increases, then ionization energy increases and decreases. That's why O2 minus less than O minus and O. Clear? If any charged particle or charged species is given, in that case, you have to explain in this way. So, factors affecting ionization energy, size increases. In short, size increases, ionization energy decreases. Effective nuclear charge, we have already mentioned, effective nuclear charge increases, ionization energy also increases. Screening effect, screen, that means nuclear charge screened by the electrons. So the outermost shell face lesser nuclear charge. So as the screening greater, then ionization energy will be less. So three important points: size of the atom increases, ionization energy less; effective nuclear charge increases, ionization energy increases; screening effect, screening of the inner electron, then the ionization energy decreases. Yes. Across the period from left to right, when we move from left to right, effective nuclear charge increases, ionization energy also increases. Can you say which element having highest ionization energy? Can you say which element having highest ionization energy? Suggest. Fluorine. Madris, কি বলছিস? Fluorine. Do you have fluorine? Fluorine দুজন বল। Highest ionization energy. তোরা কি বলছিস? হ্যাঁ, সব ফ্লুরিন বলছি। অনলাইনে যারা আছিস তারা কি বলছিস? হ্যাঁ, অনিক, ফরহান, আমি শুনতে পেলাম না। ফরহান আসলে আমেরিকা থেকে তো শুনতে পাচ্ছি না।
ও না স্যার, বলিনি কিছু।
আচ্ছা, বল। Which one having highest ionization energy? Acha, okay. First, that J size, smallest size, higher ionization energy. First period, it contains two elements, hydrogen and helium. Hydrogen having greater size because from left to right size decreases. So in the periodic table, smallest size will be that of helium. Size তো ওর ছোট, সাইজ তো ওর স্মল, ভ্যালু ওর বড় আছে, বের করা যায় না, সাইজ তো ওর ছোট। ক্লোজ সেল, হ্যাঁ, ফ্লুরিন স্মলেস্ট অ্যাটম কে বললো? না, ওটা তো ভ্যালুর জন্য। এখানে তো ইলেকট্রন বের করতে হবে এনার্জিটা। এনার্জি সব থেকে কার বেশি লাগবে? হচ্ছে ক্লোজ সেল। ইনার্ট গ্যাসের আয়নাইজেশন এনার্জি সবসময় বেশি হবে। ইনার্ট গ্যাস, ইফ ইউ ওয়ান্ট টু রিমুভ ইলেকট্রনস ফ্রম inert gas do not take part in any sort of bond formation or any reaction. Why? Because those electrons are present in inert gases, those are stable, it contains closed cell. So highest ionization energy helium, and highest ionization energy helium, lowest ionization energy cesium or francium. Because francium, we most of the time do not consider francium because francium is radioactive. Francium is radioactive, so we do not consider francium as such. But radioactive means it easily dissociates. So francium is not stable. That's why you can consider cesium, and highest ionization energy is helium. আমি একটা লিস্ট বানিয়ে দেবো, ছোট বড় কার এরকম একটা লিস্ট তৈরি করে দেবো, সেই লিস্টটা দেখবে। Ionization enthalpy from left to right, ionization energy increases. শোন, আমি একটা কথা বলি, ভ্যালু তোমার কাছে অ্যাভেলেবেল নয় মানেই ওর সাইজটা অ্যাকচুয়ালি বড় এরকম নয়। তুমি যখন কম্পেয়ার করবে তখন কম্প্যারিজনটা একই অর্ডারে হতে হবে। অন্যদের কোভ্যালেন্ট রেডিয়াস আর ওর ভ্যান ডার ওয়ালস রেডিয়াস কম্পেয়ার হবে না। ও যদি কোভ্যালেন্ট রেডিয়াস হতো তাহলে কিরকম হতে পারতো সেই হিসাবেই করতে হবে, ঠিক আছে? তো ionization energy increases due to the decrease in atomic size decrease, and ionization energy increases lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They contains same cell, but the number of electrons and protons increases, so force of attraction increases, size decreases, ionization energy increases. As we move down the group, size increases, ionization energy decreases. Down the group, so from left to right, ionization energy increases, and down the group, ionization energy decreases due to increase in size. Here you see that sodium, it contains 3 cells. Sodium, how many cells? Sodium 281. 281. So attraction between nucleus and third cell. Here from you remove this electron. But when you consider potassium, it contains 4 cells. 2881. So here electron should be removed from fourth cell. So greater distance, here lesser distance, here greater distance. So greater amount of energy required as we move down the group. Here also you can say that rubidium, fifth electron removed from fifth cell. Cesium, electron removed from sixth cell. Francium, electron removed from seventh cell. That is the
shell increase or more ionization?
less ionization energy, atomic size increase করছে, ionization nuclear charge increase করছে, but the ionization energy decreases because size increase is more, size effect is more. Comparison of ionization energy. Two exceptions in the second period. Two exceptions in the second period. Two exceptions, just write down those exceptions. As we already mentioned that like left to right, left to right, left to right, it is expected to be left to right ionization energy increases. But there are two exceptions. Beryllium is greater than boron, and here you see that nitrogen is greater than oxygen. There are two exceptions. Beryllium having higher ionization energy with respect to boron, and nitrogen having higher ionization energy with respect to oxygen. উল্টো হয়ে গেছে, এই nitrogen is expected to be less than that of oxygen, but actually nitrogen having greater ionization energy with respect to oxygen, and also in case of beryllium and boron. Only these two exceptions. There are so many exceptions, but you just read these two exceptions. Nitrogen and oxygen and boron and beryllium, just opposite. Here you see that if you consider some values, see beryllium, boron 899, 801. So beryllium having higher ionization energy than of boron, but the size of beryllium is greater with respect to boron. Boron is smaller, beryllium is greater. So expected that beryllium having less ionization energy, but not so. Here also see that nitrogen 1402 and oxygen 1314. Only these two exceptions here and here. Other values are as usual. Here neon is highest ionization energy. Just see the value. If neon is greater in size with respect to fluorine, then its ionization energy, why its ionization energy is so high? So neon do not have greater size with respect to fluorine, but we don't have any value, any covalent radii value. That's why we determine the van der Waals radii value for neon. Actually, the size of neon is less than that of fluorine, not greater. But we have no literature value to compare it. Okay. As we move down the group, lithium, sodium, potassium, rubidium, cesium, francium, there is no exception. No exception. But the rate of decrease, some sort of changes. Rate of decrease means, just see that lithium 520, sodium 496, less, but not too less. 496 to 419 potassium. Now here you see that 403, 374. Here the decrease is not so great. Here decrease is maximum. এসব পড়তে হবে না, আমি জাস্ট দেখালাম যে always the decrease is not regular. Regular means same decrease, similar decrease in same period, not always happen. There are so many different factors are there. Just you have to remember from lithium to cesium, the ionization energy value decreases because size increases in the group. Now, you have some conception about ionization energy, you can use this value to determine, to compare the other different properties like metallic character. Metallic character, it is just see which elements present in the periodic table are called as metals. The elements present in the left hand side of the periodic table like sodium, potassium, calcium, aluminium, all those elements are present left hand side of the periodic table. Now the elements present in the right hand side of the periodic table like oxygen, sulfur, fluorine, chlorine, those are non-metals. Now this, how to explain this fact? Metals are electropositive, they can easily remove electrons. Metals are positive and non-metals are negative, they can attract the electrons. So if you consider the electrons present, elements present in the left hand side of the periodic table, all the elements present in the left hand side of the periodic table, they having greater size. So they have tendency to lose electrons. That means they have low ionization energy. So metallic character is inversely proportional to the ionization energy. The elements having low ionization energy considered to be metal because they have greater size. If you consider lithium, sodium, potassium, all the elements present in the very first period, first group, and after that as we move left to right, the size decreases. So tendency to remove electron also decreases. So elements present in the left hand side, those are considered to be metal because of the fact that they have greater size, they have higher tendency to remove electrons. So that's why generally for metals ionization energy is low and generally for non-metals ionization energy is high. We can say that metallic character is inversely. So as we move from left to right in the periodic table, how metallic character changes? Metallic character decreases. As we move down the group, metallic character increases because ionization energy decreases. If ionization energy decreases, metallic character increases. If ionization energy increases, then non-metallic character increases. So as we move from left to right, metallic character decreases, non-metallic character increases. As we move down the group, then metallic character increases. Just consider that fluorine is a non-metal, or oxygen, nitrogen, those elements are non-metal. But as we move down the group, you see that the elements present down the group, they have some sort of metallic character. Like carbon. Carbon is a non-metal. Silicon is a metalloid. Some sort of metallic character arises. Carbon, silicon, germanium, tin, lead. Now carbon is non-metal, but as we move down the group, we get the lead. Lead is a good metal. So the elements present in the right hand side, they are considered to be non-metal, but as we move down the group, metallic character increases. Like if you consider oxygen, sulfur, selenium, tellurium, polonium. Polonium is a good metal. Just see nitrogen, phosphorus, those are non-metal. Arsenic, antimony, those are metalloids. Non-metal, after that metalloid. Arsenic, antimony. Bismuth is a good metal. So as we move down the group, metallic character increases. Because the size increases, elements have greater tendency to remove electrons, and the elements having greater tendency to remove electrons considered to be metal. So generally for metal, ionization energy is non-metal, ionization energy is high. Now another one, the reactivity of metal. How? A metal is reactive. Sodium is reactive. Potassium is reactive. Now how you should consider the reactivity between sodium and potassium? Now see, that why sodium is reactive? Because sodium contains one electron in its outermost shell and it releases one electron to gain its electronic configuration like neon. And potassium, it also contains one electron in its outermost shell It can easily remove that electron to get the electronic configuration like argon. Now consider sodium and potassium. Which one having greater size? Potassium, because potassium placed below that of sodium. So which one easily remove electrons? Potassium. Which one will be more reactive? Potassium. That means lower ionization energy, greater reactivity. What is the application of ionization energy? From the knowledge of ionization energy, which other properties we can explain? If we know the size and the ionization energy, from this knowledge we can explain the other facts like metallic, non-metallic characteristics like reactivity, etc. Here you see that lithium, sodium, potassium, rubidium, cesium, francium. Just think about that. Francium is so much reactive that you can't keep francium as it is. Within 2 to 5 seconds, it converted into other element. It is so reactive. So think francium having very large size. It can't hold its electrons. If you consider lithium, smaller size, lithium is least reactive, sodium is much more, potassium is even more, rubidium, cesium in this way. So reactivity of the metals is inversely proportional to the ionization energy. As the ionization energy less, then that element, that metal having greater tendency to remove electron. So a particular element that is reactive or not reactive, that totally depends upon how its electron participate in reaction. At the end of the day, you should consider that what is the exact explanation or not. You should consider that electrons ultimately participate in chemical reaction. So all the explanation lies in electron participation. And electron participation, that is held by the ionization energy. So if ionization energy less, then electrons can easily participate in chemical reactions and metal should be reactive. So these are the different facts. Now just see here one important thing. Sodium can be converted into sodium plus. If you consider that sodium plus is converted into sodium 2 plus. Now is it possible? Previously we have discussed that sodium is not converted into sodium 2 plus. That's why sodium chloride NaCl, it is not NaCl2. Now if the difference of energy, you can convert sodium 2 plus, then the energy difference is 42.7 electron volt, which is a very high energy. So the difference is greater than 16 electron volt. If one electron you should remove and the another electron is remove, the difference is greater than 16 electron volt. Then the lower state is stable, higher state should not be formed. The difference between the two successive ionization energy often greater than 16, lower valency state is stable. Sodium plus stable. You never convert into sodium 2 plus. But here see, magnesium. Magnesium is converted into magnesium 2 plus, magnesium plus. Again, magnesium plus is converted into magnesium 2 plus. The difference is energy is 7.4 electron volt. That means after the conversion of magnesium 2 plus, you can convert magnesium plus, you can convert magnesium 2 plus because the difference of energy is less than 16 electron volt. So magnesium 2 plus is more stable. Sodium plus is stable than sodium 2 plus, but magnesium 2 plus is stable than magnesium plus. Okay. তো আমি পাঠিয়ে দেবো আর একটা জিনিস, আমি একটা দুটো কোশ্চেন এখানে দেখ যে how many electrons present in the outermost cell? How many electrons present in the outermost cell? If a particular element contains one electron in its outermost cell, then after the removal of first electron, the second electron removal is the sudden jump over there. Sudden jump. Like here you see that first electron remove energy 5 kilocalorie. But second 100 and third 120. What does it mean? That means it contains valence electron number is 1. Because after first, second will be greater. But the difference is very large. Now second cell contains 2 or 3 electrons. Here 100, 120, 140. Now, then you see 500 or 600. Then when sudden jumps over there, then that means inner cell, outermost cell, all the electrons are removed. Then you come to the inner cell. If suppose, think about that. Aluminium contains 3 electrons in the outermost cell. First electron 5 kilocalorie, second electron 7 kilocalorie, third electron 12 kilocalorie, fourth electron 70 kilocalorie. How that happened? Because it contains 3 electrons in the outermost cell. First electron removed, second electron removed, third electron removed. After that, inner cell, electrons removed from the inner cell. So inner cell having greater attractive force. So electron, in order to remove that electron, greater energy is required. That's why aluminium removes only 3 electrons. তো আমরা এই পর্যন্ত বললাম অ্যাপ্লিকেশনস অফ আয়নাইজেশন এনার্জি। নেক্সট ক্লাসে আমরা এটাকে কমপ্লিট করব, অ্যাপ্লিকেশনস অফ আয়নাইজেশন এনার্জি।
তাহলে এটা তো নিলস বোরের যে অ্যাটমিক মডেল ছিল ওটাকে তো প্রুফ করছে,
সবই প্রুফ করছে। ঠিক আছে, আজকে পর্যন্ত থাকলো। ওকে, থ্যাংক ইউ। অনলাইনে যারা আছিস আমি এটা পাঠিয়ে দেবো, ভিডিওটাও পাঠিয়ে দেবো। এগুলো একটু এটা ভালো করে পড়তে হয়, তার কারণটা হচ্ছে যে এখানে কিন্তু অনেকগুলো ফ্যাক্ট রয়েছে, অন্য চ্যাপ্টারগুলোতে কাজে লাগবে, তাই আমরা একটু সময় নিচ্ছি। ওকে, থ্যাংক ইউ, বাই।
বাই স্যার, থ্যাংক ইউ।
হ্যাঁ, চাবিটা তো দাঁড়া দিচ্ছি।